Hello friends, welcome to the Fastrack video on sequential circuits. This video is going to cover all the important topics that is very much important for competitive exams. Hello friends, this is Arun Kumar here. I welcome you to my channel Craving Gyan. In this video we are going to revise. The first topic is we are going to compare and contrast with respect to combinational circuits and sequential circuits. Nothing but we are going to know what is the basic difference between a combinational circuit and a sequential circuit. The next topic we are going to talk about what is the need for sequential circuits. Even though we are having combinational circuits, we are going to talk about what is the need for sequential circuits. In the sequential circuits, the first topic we are going to revise what do you mean by latch. We are going to compare what is the advantages of using flip-flop over latch. Next thing is we are going to talk about latch conversion or flip-flop conversion. Nothing but from one flip-flop to another flip-flop you are going to make a conversion. What is the standard procedure? All those things I am going to discuss. The fifth topic I am going to talk about 5 variants of flip-flop. We are having SR flip-flop, JK flip-flop, JK master slave, D and T flip-flop. We know that SR flip-flop, JK master slave will be having two inputs, but if I am talking about D and T flip-flops, it will be having a single input. Now, the sixth topic we are going to talk about is what do you mean by register and counter. We know that a flip-flop is a bistable element which can store a single bit of information that can be either logic 0 or logic 1. Group of flip-flop, nothing but if I am combining some n flip-flop, it is going to store n bit of information. In turn, I can tell it is of n bit register wide. And in the case of counter, we are going to talk about synchronous counter, asynchronous counter and hybrid counter. We are not going to stress more about hybrid counter. Also, the important topics in counters are up counter and down counter. MCQs will be based on you have to design a counter or given a circuit you have to tell what is the modulus of the counter. So these kind of questions are very important if you are preparing for UGC NET exams as well as GATE exams. The miscellaneous topic is you have to know what is the basic difference between a Mealy model and Moore model. If you are preparing for explicitly for UGC NET exams, you should know the difference or basic difference between Mealy model and Moore model is more than enough. So friends, this is the Fastrack video. For detailed explanation, links are provided in the description. Please go through it. In my previous video, we have come up with the Fastrack revision on combinational circuit. If you have not watched that video, links are given in the description. Also, you can click on I button. Now, if I am talking about combinational circuit and sequential circuits, in the case of combinational circuit, output depends only on the present input. But in the case of sequential circuit, output not only depends on present input, also it depends on past output also. Nothing but it will be having memory. In the case of combinational circuit, it will not be having memory. In the case of combinational circuit, it will not be having even feedback also. But in the case of sequential circuits, feedback do exist. So I can relate combinational circuits with open loop system and the sequential circuits I can relate with respect to a closed loop system. If you want to design a closed loop system, it is very much simple. Similarly, combinational circuits are very much simple, but sequential circuits, circuit design is bit complex. Now, if I am talking about the examples of combinational circuits, examples are adders, subtractors, code converters, etc. But in the case of sequential circuits, flip-flops, counter, register will fall under the examples of sequential circuit. In the case of sequential circuit, basic element you need to talk about is flip-flop, because flip-flop is the one which is going to store the data. Now, in order to realize the memory, let me make use of an inverter. So for this inverter, if I am applying logic 0, I will be getting logic 1. If I am giving logic 1 as my input, I will be getting logic 0. Say suppose I am making use of two inverters, nothing but a buffer. If I am giving logic 0, I will be getting logic 1 over here. Here I will be getting logic 0. If I am giving logic 1, I will be getting logic 0. Here I will be getting logic 1. This data I can fed back. So this is what I made. Next, the first inverter I have connected over here. The second inverter I have connected over here. The output of the first inverter is connected to the input of the second inverter. So the output of the first inverter is connected as input to the second inverter. The output of the second inverter is connected as input to the first inverter. So cross coupled connection I have made. So this is about the latch connection. So in the case of monostable multivibrator, you will be having a single stable state. But in the case of bistable multivibrator, you will be having two stable state. In the case of astable multivibrator, you will not be having any stable states. If you are realizing even number of inverters, you are going to realize bistable multivibrator nothing but you are going to realize memory. If you are making use of odd number of inverters, you are going to realize unstable multivibrator. The output of unstable multivibrator will be something like this: charging, discharging, charging, discharging. So this one, if you are connecting to a 555 timer, you can able to generate a square wave or a rectangular wave thereby. So clock generation you are made, nothing but you are going to design a oscillator based on a stable multivibrator design. Now if I am talking about monostable multivibrator, you will be having a single stable state where exactly you are going to make use of this monostable multivibrator. So when you want to realize a trigger pulse or when you want to generate a trigger pulse, at that time you are going to make use of this monostable multivibrator circuit. Say suppose you have come up with this instrument, insert a coin, your weight will be shown. So that is something like a monostable multivibrator design, or coffee vending machine, so it falls under monostable multivibrator design. But if I am talking about bistable memory storage, and for clock generation we are going to make use of unstable multivibrator design. So this is very important. Thereby I can relate digital electronics with analog. Before getting into flip-flops, let us realize or let us talk about NOR based latch and NAND based latch. So in the case of NOR based latch, I am going to consider A and B are my inputs, outputs are Q and Q bar. If my data inputs are 0 and 0, output is going to retain the previous state. 0, 1, you will be getting 1, 0, nothing but a set state. We are going to concern, or we are very much concerned with respect to Q, because Q is always complement of Q bar, or Q bar is always complement of Q. So Q bar is nothing but for complement outputs wherever you want. At that time you are going to make use of Q bar signal, but actual output is Q. If my inputs are 1, 0, I will be getting 0, 1, nothing but it is a set state. Whenever my inputs are 1, 1, most of the textbooks they will be telling it as forbidden state. It is not a forbidden state. Whenever 1, 1 is followed by 0, 0, you will be getting 0, 1 or 1, 0 based on this NOR delay. And that state you are going to call it as a forbidden state. I am going to put up a link in the description, or else you can click on I button, how NOR based latch. In the case of NOR based latch, whenever 1, 1 is given to a NOR based latch, you will not be getting forbidden state. Whenever you are giving 1, 1 followed by 0, 0, you will be getting a forbidden state. So this one I have explained in detail. Similarly, in the case of NAND based latch, whenever you are going to provide 1, 1, you will be getting a previous state. 0, 1, you will be getting 1, 0. 1, 0 if you are giving, you will be getting 0, 1. 0, 0 followed by 1, 1. It is a forbidden state in the case of NAND based. Remember one thing, in the case of latch, whenever you are going to give 0, 1, you will be getting 1, 0. But in the case of flip-flop, if you are giving 0, 1, you will be getting 0, 1 only. Nothing but a reset state you will be getting. If you are providing 1, 0, there you will be getting 1, 0. But here you will be getting 0, 1. So basic difference between a latch and a flip-flop you should know. In the case of latch, you will be having only inputs, but in the case of flip-flop, you will be having one master input. That one you are going to call it as a enable signal, or you are going to call it as a clock signal. Now, if I am talking about why we are not going to prefer latch, or what is the use of making flip-flops. Flip-flop is going to remove, or it is going to nullify, or it is going to minimize the noise interference. Noise interference is more in the case of latch, so we are not going to prefer latch. So in the case of latch, so this is your NAND based latch and this is your NOR based latch. So here you are going to provide a master input. Here you are going to provide a master input which looks something like this. So this is a SR latch. So in this SR latch you will be having a control signal. So whenever control is 0, output is going to follow the previous state. Whenever control is 1, output is going to follow the logic. Whenever my inputs are 0, 0, it is going to follow the previous state. Whenever it is 0, 1, it is reset. Whenever it is 1, it is set. Whenever it is 1, 1 followed by 0, 0, there you will be getting a forbidden state, or it is an unknown state. So this one also I have explained in detail. If you have not watched this video, links are provided in the description. You can please go through it. So the characteristic table of a JK flip-flop, you will be getting for 0, 0 it is previous state. For 0, 1 you will be getting reset. For 1, 0 you will be getting set. For 1, 1 instead of getting a forbidden state or an unknown state, you will be getting a toggle. So switch bounce effect you are going to eliminate with the help of SR latch or SR flip-flop. So this forbidden state is overcome with the help of JK flip-flop. Able to follow? Now if I am talking about a D latch, in the case of D latch and T latch, you will be having a single input. So the single input I am going to provide over here, this SR or JK. For this SR and JK, you are going to connect a inverter. So this is how you are going to convert SR to D or JK to D flip-flop or D latch. So the characteristic table is, whenever my input is 0, output is going to follow the previous state. Whenever input is 1, output is going to nothing but the data is getting transferred. In the case of T latch, whenever my input is 0, output is going to follow the previous state. Whenever my input is 1, at the time output toggles, nothing but if output equals to 1, I will be getting 0. For the next state, you will be getting 1, 0, 1, 0, and this state continues. So you have to remember the characteristic table, or main thing is you have to remember the characteristic equation of each and every flip-flop. So this is very, very important. If you want to convert from SR to JK or JK to SR, SR to D, SR to T, at the time interconversion time, you need to remember this characteristic equation. Now if I am talking about the characteristic equation of SR, so the characteristic equation of SR is this one. So this table you have to remember. So this one I have written over here. Whenever my inputs are 0, 0, whenever my inputs are 0, 0, next state will be the previous state. Next state will be the previous state. Whenever my inputs are 0, 1, output is going to be reset, nothing but 0. Whenever my inputs are 1, 0, output will be set. Whenever my inputs are 1, 1, you will be getting a forbidden state. Whenever my inputs are 1, 1, you will be getting a forbidden state or an unknown state. So excitation table, how you are going to draw means, based on Q of n and Q of n plus 1, you are going to derive what is the values of S and R, or what is the expression for S and R. For 0, 0 means you are going to take this expression 0, 0 and this is 0, 0. Here S is not changing, R is making a flip or a transition. So you are going to write it as 0, don't care. Next you will be getting 0, 1. 0, 1 means take this one. 0, 1 you will be getting 1, 0. For 1, 0, you will be getting 0, 1. And for 1, 1, let me take this one, 1, 1 and this one, 1, 1. So S is making a transition, R is not making a transition. At that time you will be writing it as don't care, 0. So you came to know what is Q of n and Q of n plus 1. They are inputs. What is output? S and R. So how you are going to realize means S, R, Q are my inputs. S, R, Q are my inputs. What is the next state? So make use of this table, fill over here. So you will be getting characteristic equation as S plus R bar Q. So this one I have explained in detail. If you have not watched that video, links are provided in the description. Please go through it. And this table you have to remember. This excitation table is very, very important, and this characteristic equation table you have to remember. So this is very, very important. So in the case of JK, instead of writing that forbidden or an unknown, you are going to write it as Q of n bar. So that is a simple change. So you'll be getting the characteristic equation as JQ bar plus K bar Q. D means it is D only. Now look at over here, the characteristic equation D Q of n. For 0 you'll be getting 0, for 1 you'll be getting 1. So D and Q of n are my inputs. Q of n plus 1 is next output. So whenever my inputs are 0, 0, output is 0. So whenever it is 0, 1, nothing but D is 0. Output you will be getting Q of n, nothing but 1 if you are getting, then the next state will be 0 only, because input is going to get transferred. Whenever my input is 1, present output is 0, next output should be 1. 1 means you will be getting a data that is getting transferred. So in the case of excitation table, you are going to make use of Q of n and Q of n plus 1. You are going to derive what is input. So input is 0, 1, 0, 1, nothing but characteristic equation of D will be the same. If you are making use of SR to D, the characteristic equation of D will be the same. So whatever the output you will be getting, the same thing you are going to retain in the case of D. Next, let us talk about T flip-flop or T latch. Whenever my inputs are 1, at that time you will be getting a toggle, nothing but Q of n bar. If it is 0, I will be getting 1. If it is 1, I will be getting 0. For 0 to 0, is there any transition? No, right? So it is 0. For 0 to 1, is there any transition? Yes. For 1 to 0, is there any transition? Yes. For 1 to 1, is there any transition? No, right? So it is 0. 0, 0 means this state. For 0, 0, you will be getting 0. For 0, 1 means 0, 1 means you will be getting 1. So I have written 1. For 1, 0, for 1, 0 means it is this one. For 1, 0, I will be getting T as 1. For 1 1 it is 0. It is 0. So the characteristic equation of T will be T XOR Q of n. So this is very important. Again I am going to repeat. In the case of SR it is S plus R bar Q. In the case of JK it is J Q bar plus K bar Q. In the case of D it is a D only. In the case of T it is T XOR Q. Now let us learn how we are going to convert, or what is the standard procedure of conversion from a one flip-flop to another flip-flop or one latch to another latch. Example is, if I want to convert SR to JK. So what is the first step is, write truth table for required flip-flop, extend with the given flip-flop inputs. Say suppose if I want to realize SR to JK. So first thing you have to consider JK, write JK. What is Q of n? What is Q of n plus 1? Fill up the table. Then later you have to realize SR. If I want to realize SR to T, first what you have to do is make use of T. T Q of n plus 1. Based on this you have to realize SR. So which one you want to realize? Write it first. They are telling. What is the second step is, for given flip-flop, input column must be filled with the excitation table. So excitation table of all the flip-flops you have to remember. This is very important. If you are unable to remember with the things on spot, you have to derive. This is very important. How to derive I have explained in the previous videos. Now what is the third step means, find Boolean expression for given flip-flop inputs in terms of flip-flop inputs and Q of n. At last you have to draw the logic diagram. This is very important. Now in the case of latch or flip-flop conversion, say suppose if I want to realize SR to JK. So JK Q of n plus 1 is my next output. So 0 0 0, nothing but if my inputs are 0 0, output is going to retain the previous state. If my input is 0 1, output will be reset. If my inputs are 1 0, output will be set. If my inputs are 1 1, output is going to get toggle, nothing but 0 becomes 1, 1 becomes 0. Now we came to know what is Q of n and Q of n plus 1. Now we have to derive what is SR. Now for 0 0, the thing is you have to remember the characteristic equation. The characteristic equation is something like this. So for 0 0 it is 0 don't care. So for 0 0 it is 0 don't care, right? For 1 1 it is don't care 0. For 0 0 it is 0 don't care. For 1 0 it is 0 1. For 0 1 it is 1 0. So like this you have to remember. Main thing is you have to remember the table, and then you have to make use of a K map, realize the expression for S and realize the expression for R. For S you will be getting JQ bar, and for R you will be getting KQ. So finally you have to realize the table. So S is my input, R is my input, but what is S? It is JQ bar. J is one input, Q bar is another input. Make use of an AND gate. So R is my input. For R it is KQ. So K is one input, one more input is Q. So for AND operation I am going to make use of an AND gate. So this is how you are going to realize SR to JK. For each and every flip-flop I have made an exclusive video. All the links I have put up in the description. Please go through it. Next topic is interconversion of flip-flops or latch. If you don't want to realize on spot, or if you don't want to derive on spot, if you can able to remember, it's well and good, or else you have to derive on spot. So for SR to other flip-flop, so S equals to JQ bar plus R equals to KQ, already we have known. And for D it is S equals to D and R equals to D bar. But in the case of T it is S equals to TQ bar, R equals to TQ. All these things you have to remember. Please go through it and take a snapshot of this. This is very important. Now if I am talking about the basic difference between a latch and a flip-flop. So a flip-flop is a bistable element which can store a single bit of information. That information can be either logic 0 or logic 1. Cross-coupled NOT gate is a latch. So in the case of latch, it is a level trigger, nothing but the signal will be enabled for a particular duration. But in the case of flip-flop, it can be edge triggered or level triggered. It can be level triggered also, but for application point of view we are going to make use of edge triggered circuit. This is very important. And noise interference is more in the case of latch. Thereby you are going to introduce a master signal, that is a clock. So in flip-flops, noise signal or noise interference is less in the case of flip-flops. So applications of latch includes, so this is very important. Not many textbooks will be talking more on latches. Directly they will get into flip-flops. So one practical application of latch is in buzzer, nothing but in a quiz competition, who has pressed the buzzer first. At that time, to know the things, we are going to make use of latch. But in the case of flip-flop, used in memories, register, counters, etc. Latches, most of the practical applications we are not going to make use of latch. Most of the cases we are going to make use of a flip-flop only. The definitions of this are very important if you are preparing for competitive exams. What do you mean by T flip-flop delay or T clock to Q? It is nothing but time required to change the flip-flop output from clock edge occurrence. What do you mean by setup time and hold time? So this question they have asked a number of times. So setup time means minimum time required for the inputs to be stable before occurrence of clock edge. But what do you mean by hold time means minimum time required for the inputs to be stable after clock edge occurrence. Nothing but if you want to execute a program, it should be readily available. So that is setup time. Once it is executing, you should not interrupt it. So after finishing execution, you have to wait for some more time. That is something like a hold time. So practical examples also I have shared, nothing but a passing of brick, how you are going to maintain setup time as well as hold time. All those things I have discussed. Now if I am talking about the definition of race on condition, complementing the output more than once in one enabled duration. That is the definition of race on condition. They may ask you a question, will race on condition can occur in combinational circuits? At that time it may occur because of a faulty design. If you are making, definitely race on condition will occur. Nothing but whenever two inputs are propagating, so or the output, it has to be arrived at the same time. If there is any delay, at that time race on condition will occur. Nothing but two signals are in a race. At that time your outputs will get flipped. So this is what I mean by race on condition. They may ask you a question, race on condition, will it occur in a flip-flops? Will it occur in a combination circuit? Will race on condition appear in a Mealy model or Moore model? All these things they will be asking. So when race on condition will occur means whenever we are going to make use of level triggered latch with input condition which gives complemented output, or if enabled for longer duration than a latch delay, at that time definitely race on condition will occur. How we are going to eliminate this race on condition means you are going to decrease the enabled duration of a latch, nothing but T on time you are going to reduce, and you are going to increase the latch delay, that is delta you are going to increase. And instead of making use of level triggered, nothing but it is used in latch, you are going to make use of a edge triggered one. Race on condition occurs in combination circuits when there are multiple paths or delay mismatch. So this line is very important, you have to remember, because in the case of race on condition, useful of memory is wasted. This is very important. Now if I am talking about a counter is a sequential circuit which goes through predefined state, and counters are used in frequency division. It is used for counting number of clock pulses. It is also used in timers. It is also used in frequency measurement as well as waveform measurement. Say suppose if you are having a 1 megahertz clock, if you want to divide by 2 or divide by 4 or divide by 8, at that time you are going to make use of a counters. And again you can go with synchronous counter and asynchronous counter. In the case of synchronous counter means it is a parallel counter. If you are making use of an asynchronous design, it is a ripple counter. For a modulus n counter can go a maximum of n stable state. This is very important. Example, mod 3, if I am designing, mod 3 means it will be having a 3 stable state. It can be 0, 1, 2 or 0, 4, 6 or 0, 9, 12. So modulus 3 means it will be having 3 stable states. The 3 stable states can be anything. But if I am telling mod 3 means most of them will be thinking that 0, 1, 2 is mod 3. For n flip-flops, modulus will be mod of 2 power n. This is very important. And in the case of counters, up counter design as well as down counter design is very important. So they may ask you what is the modulus of a given circuit. So at that time you should be in a position to answer. Now if I am talking about synchronous counter, you need to talk about ring counter. Also you need to talk about twisted counter or Johnson counter or switch tail counter. Main thing is For an MCQ, they will be asking maximum modulus. In the case of ring counter, you have to tell it is n. Again, I am telling it is maximum modulus. Maximum modulus of a twisted counter is 2n. Nothing but if input frequency is f, here you will be getting output frequency as f by n. But here output frequency is f by 2n. So maximum counts is 2 power n minus 1, but here also it is 2 power n minus 1. So the basic difference between a ring counter and a twisted counter you should know. So this is very, very important. Now if I am talking about serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out, what is the computation time? So in the case of serial in, serial out, it is 2n minus 1 times of t clock. Serial in, parallel out, it is n times of t clock. PSO, nothing but parallel in, serial out, it is n times of t clock. And in the case of PPO, nothing but parallel in, parallel out, you require only one clock cycle. Example is you can make use of a flash converter. So in the case of flash converter, computation time is only one clock cycle. Now this topic is very, very important. In the case of asynchronous counter or ripple counter, you need to talk about up counter, down counter, up down counter. In the case of up down counter, you will be having only one signal. So if the signal is low, it will be acting like an up counter. If it is high, at that time it will be acting like a down counter. This is very, very important. Main thing is they will be talking about the average power. Average power, how you are going to calculate means V square divided by T into duty cycle. That is T on divided by T on plus T off. While designing a circuit, you need to consider about setup time and hold time. I am telling you, questions will be asked based on setup time and hold time if you are preparing for gate exams. Maximum operating frequency is given by F max, which is equals to 1 divided by T min. What is T min? It is T clock to Q plus T combination plus T setup time. If you are preparing for competitive exams like gate or engineering service examination, without this formula, you should not take the exam. And T clock to Q plus T combination should be greater than T hold. So these two are necessary and sufficient condition. Flip-flop to flip-flop, if I am calculating a delay, then it is a synchronous design. Flip-flop through flip-flop, if I am calculating, then it is an asynchronous design. So these two things you have to remember. Next topic is, let us talk about secondary inputs. In the case of secondary inputs, we will be having two inputs, that is preset and clear. Let me consider a black box. So in this circuit, you will be having some set of inputs. You will be having some set of inputs and you will be having some set of outputs. So if you are making use of preset and clear, if you are making use of preset and clear, say suppose if I am enabling preset, so irrespective of input, my output will become 1. Now if I am making use of clear, irrespective of my input, output will be 0. So whenever I am making preset equals to 0 and clear equals to 0, that is, it is going to execute a normal operation. Based on input, based on the functionality, I will be getting a output. But say suppose if my preset equals to 0 and if I am making clear as 1, nothing but I am enabling clear, at that time output should be equals to 0. If I am making preset as 1, nothing but I am enabling preset and I am disabling the clear, then output equals to 1. If I am making preset as 1 as well as clear as 1, nothing but output node is getting pulled to 1, simultaneously it is pulled to 0. So it is an invalid operation. So whenever you are going to turn on the circuit, at that time you are going to make use of this inputs, that is preset and clear. Whenever your counter is getting into an unknown state, at that time you are going to make use of this preset and clear inputs. Now the last topic or the miscellaneous topic is finite state machine. In the case of Mealy model, output is a function of input as well as state value. But in the case of Moore model, output is a function of state value. So in my next video, I'm going to come up with an example how you are going to realize a Mealy model and Moore model. So the basic difference is, in the case of Moore model, one extra state you are going to use in order to represent the output. But in the case of Mealy model, if I'm talking about the circuit complexity, Mealy model is very much complex when compared to Moore model. And if I'm talking about the speed of operation, Mealy model is slow because it is waiting for the input. Whereas a Moore model, it will not be waiting for an input because it will not be a function of input. So output is a function of only a state value. So example is ATM machine, all those things, you're going to make use of an input as well as the next states. So Mealy model, the perfect example is a ATM machine. So in this video, we have come up with the Fastrack video on sequential circuits. In the next video, we are going to talk about analog to digital converters and digital to analog converters. In the case of DTA converters, we need to talk about R to R as well as weighted type. But in the case of A to D, we need to talk about counter type, flash type, successive approximation register type. The fourth one is dual slope or integrating type. So these things are very important. Also, I need to talk about logic families. At least one question you will be getting in UGC NET exams as well as GATE exams on logic families. So these two topics are very important. If you have followed this quick revision video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.